In this video, you will learn about different types of ions, so monatomic ions and polyatomic ions. Just as a review, remember that ions are created by gaining or losing electrons. Right? And you have a charged particle. If it's positively charged, it is called a cation, and if it is negatively charged, it's an anion. In the previous video, we learned about how atoms form ions, right, based upon the octet rule. And you were going to learn that, group 1A, right, they all have one outer electron, so they lose it to get to the octet, and they become +1 cations. Group 2 becomes 2+ cations. Aluminum, zinc, cadmium, and silver, right, those are also, you need to learn these because they don't change. The transition metals also form cations, but their charges can vary. Right? But group 1, group 2, aluminum, zinc, cadmium, and silver don't change. So those are always constant. The halogens, they only need to pick up one more electron, right, for the octet. So they all are 1-. Oxygen, sulfur, selenium, and tellurium, they need to gain 2, therefore they're always 2-. And group 5, right, for nitrogen and phosphorus, they pick up 3 to get to the octet. So these are known as the monatomic, one atom ions. So it's the ion of just one atom. Okay, so you're able to predict those charges of the monatomic ions just based upon their position on the periodic table. So take a look at the names of the ions here, right? And see if you notice any patterns. So here's oxygen, that's called the oxide, right? Ion, sodium, 1+ is sodium ion. Nitrogen, 3-, it becomes the nitride ion. Aluminum is aluminum ion, etc. Okay, so hopefully looking at these names, the pattern you should pick up on is if it's negative, right, it ends in ide. Right, so oxide. Here's a negative, it's nitride. There's another negative, chloride. There's a negative fluorine, fluoride. So remember, the nonmetals become the anions, and their name will end in, right, IDE. Right? Whereas the cations, right, sodium, aluminum, magnesium, potassium, they keep their elemental name, right? Nothing changes. Okay, but for oxygen comes oxide, nitrogen, nitride, chlorine, fluoride, fluorine. Did I say fluoride? Chloride, and then fluorine becomes fluoride. Okay, so it ends in IDE if it's the anion. Okay. There's also another group of ions that we need to learn, and they're called the polyatomic ions. Poly, right, for many atom ion. So it is a group of atoms that are connected together, and they contain an overall charge. So here's an example of 2 polyatomic ions, sulfite and sulfate. So here's sulfite. It's a sulfur with 3 oxygens, all together carrying a -2 charge. So that's a mini atom ion. So they're all stuck together. And here's sulfur with 4 oxygens carrying a -2 charge, and that one's called sulfate. Now remember up here, sulfide, well, that's monatomic. That's a monatomic ion. It ends in ide because it's a negative charge. So sulfur alone can carry a -2 charge. It's called sulfide. And we notice the polyatomic ions end in ite or ate, right, in general. There's always exceptions. Okay. We do need to learn a good number of these polyatomic ions because they're very, very common. So here's just some examples. Here's ammonium hydroxide. That's like in Windex, a glass cleaner. Ammonium is a polyatomic ion, so is hydroxide. So that's two different polyatomic ions. Here's calcium sulfate. Okay, so sulfate ion that we talked about. This is found in gypsum and plaster molding. And here's sodium nitrate. Right, that's a polyatomic ion, nitrate, found in fertilizer. So these substances are so common that you need to learn these names. Here's just one more example. Calcium carbonate. And carbonate is a polyatomic ion, and this is what causes the hard water buildup, right, in pipes or the water, the soap scum in your shower. All right, so let's learn a bunch of polyatomic ions. So I like to teach it using the periodic table. So you see the trends and you are memorizing less and using the periodic table more. So this is a section of the periodic table in the upper right-hand corner, right, where the nonmetals are. So it's the same organization as the periodic table. Many polyatomic ions are going to be bound to oxygen, so we're not going to include them. And fluorine doesn't make polyatomic ions, so we're going to cross those two out, okay? Now, I just call this being on the 7, so it looks like the number 7. It simply looks like a 7. Okay? And then this group right here is inside the 7. Okay, so if you're an element and you're located on the 7 and your name ends in 8, that means you're going to have 3 oxygens. Okay, for example, if you're chlorate, that means you have ClO3. Bromate, you'll have 3 oxygens. Iodate, 3 oxygens. Okay. Borate, 3 oxygens. Carbonate, 3 oxygens. Nitrate, 3 oxygens, etc. Okay, so very easy. Remember, 8 is kind of the basic name, right? The standard name ending in ATE. Now, if you're on the inside of the 7, okay, so if you're in this group, right, and your name ends in 8, let's just use a different color, ends in 8 here, you'll have 4 oxygens. So phosphate would be PO4, sulfate, SO4, arsenate, ASO4, etc. Selenate and tellurate. Okay. So that's how you figure out how many oxygens the polyatomic ion has. Now let's go over the charge. So for each polyatomic ion, you need to know the name, the formula, and the charge. Okay. So if we draw a line right here, and we look at the top row only, I kind of think of oxygen as a 0 point, and it's like a number line. This one's -1. Actually, I should write 1 minus. Hold on. Actually, we don't even write, just a negative. So 0, -1, -2, -3. Okay, so those are the charges for the top line only. Okay. Now looking at the rest of them, they're going to have the same charge as their monatomic ion. So remember chloride, all the halogens were just, these are all the halogens, they're all just 1 away from the noble gas. Okay, so they all carried a -1. Same with these, they're all -1 charges. Okay, so chlorate, you know the name, chlorate, you know the formula, ClO3, because it's on the 7, and you know the charge, is a -1 because it's 1 away from the noble gas. Okay, this group here, they're 2 away, so they're all 2-. And this group here, they're all 3 away, so 3-. Okay. So just by using the periodic table, you now know many of these polyatomic ions just based upon their positions. Okay, so now there's another pattern to follow, and this is changing the name. You can put per in front, per-ate. You can have ite as an ending, and then you can have hypoite. Okay, so remember, starting with the basic form, which is 8. So if we know what chlorate is, right, ClO3-. Okay. Perchlorate means we add an oxygen, ClO4. Don't do anything with the charge. Charge stays the same. We just add an oxygen. The ite form, so here's ite. So this is 8 per-ate. Ite is always 1 less oxygen. And then hypo is even less, right? Hypoite, you lose another oxygen. Okay. So let's try that again. So if we know iodate, that's on the 7, it has 3 oxygens. Iodite, lose an oxygen. Hypoiodite, you lost 2. Periodate, add an oxygen. Okay, so from one of these, like, the basic form, the 8, you can use per-ite or hypoite, and you can change the formula. Okay. Nitrate, nitrite, lose an oxygen. Okay. You also need to know when you add a hydrogen, right, how it changes the polyatomic ion. If it still has a charge, right, then it is still a polyatomic ion. So for example, we have carbonate here. So this is 2-, and hydrogens are +1. So if I have a plus and a 2-, right, the net charge, right, is a -1. It's still an ion. But if I added another H, let's say I added another H, and I have H2CO3, there's no charge because the charges have balanced. And when this is the case, this is generally named as the acid. Okay. And this is no longer an ion, right? Because we don't have a charge. Okay, so we're looking at keeping the charge there. Okay, so we know this is carbonate. So it's carbon ending in 8, right, for the 3 oxygens, and that's a 2-. You add a hydrogen. Let me just erase this over here. You add a hydrogen, and the name becomes hydrogen carbonate. Or another name for it is bicarbonate. So bi means 1 hydrogen. Okay, so this one is phosphate. We add a hydrogen, becomes hydrogen phosphate. You add 2 hydrogens, it's still charged. Right? That becomes dihydrogen phosphate. Okay. Remember, this one can also be called biphosphate for the 1 hydrogen. Okay. And lastly, you have a group of polyatomic ions where you don't have a trend to follow, you just simply have to learn them. And these I recommend maybe making a flashcard, right? So you need to know, the name, thiocyanate. You need to know the formula, SCN, and the charge 1 minus. Okay, so thiocyanate, anything with thio means sulfur. Okay, and cyanate, well, you'll learn cyanide down here, right? That's the CN component. Okay, ammonium and hydronium, these are the only two positive ones. And notice when they're positive, they're ending in ium for those positive charges. Here's another exception. Let's just use a different color. These end in ide, peroxide, and hydroxide. Okay, so two exceptions. Most of them, remember, ends in ate, right, or ite. Oh, sorry, there's one more here, cyanide. So these three end in ide, peroxide, hydroxide, and cyanide. Acetate. One note about acetate, you might also see it written as CH3COO minus. And this is the ion found in vinegar, right? That's acetic acid, which is the acid in vinegar. Permanganate, it has manganese in it, so that's how you remember that one. Oxalate is carbon, right? C2O4, 2 minus. Chromate has a chromium, CrO4, 2 minus. And dichromate has 2 chromiums, Cr2O7, 2 minus. So these, you just have to learn. Okay. Here's another nice table showing some of the polyatomic ions. Also remember that the top line is a little different trend. Right? So remember the monatomic, they don't have the same charge as their monatomic. So like nitride is 3 away from the noble gas, but the nitrates and the nitrites are 1 minus. So remember it goes -1, -2, -3. All these others have the same charge, right, as their monatomic ion does. Okay. Let's do a practice here. What is the formula and charge for arsenite? Okay, so if you were back here at your periodic table and you looked at arsenic, right, you would see that here's the 7, it's inside the 7. So you should be able to come up with arsenate. So this is how I would do it. All right, I would say I know that ASO4, 3 minus, right, is arsenate. And if they're asking for arsenite, then I know that it has 1 oxygen less, but the charge stays the same for arsenite. And so that one is B.